Hello, research design and analysis students. Today we're going to be talking about graphing. Maybe you want a bar chart of frequencies to see how many people picked a certain category. Maybe you want a box and whisker plot because you're looking at the median of a group and you want to see the median, the middle 50% of the distribution, the 10 and 90th percentiles, and any outliers if you're looking at an ordinal, interval, or ratio variable. Or perhaps you want to make a histogram or a stem and leaf plot where you're looking at interval ratio data and you want to see not only the measures of central tendency, perhaps where the mean is, but also the standard deviation or variance, whether your distribution is normally distributed or skewed or tall and leptokurtic or platykurtic, kind of flat. A normal distribution on a histogram is sometimes also called mesokurtic. Mesa meaning table in a lot of languages, meso meaning middle. So we might be trying to look at a distribution of continuous data and want to see that kind of graph. So again, today if we're trying to think of frequency distributions in a graphical sense, I'm going to show you how to make a bar chart for nominal data, a box and whisker plot where you can look at ordinal, interval, or ratio data based on the median, and a histogram and stem and leaf plot that is based on the mean and standard deviation. So you actually can make these kind of graphs if you were doing descriptive statistics, and we showed this in another segment by using either frequencies, which will give you a frequency table and the option to make a histogram or bar chart, or by using explore, which will give you a box and whisker plot, a histogram, and a stem and leaf plot. But you also can go right to building the graph itself, and you can use Chart Builder and play around with it to see a lot of different ways that you could put variables together, bar charts, pie charts, scatter plots, histograms, and build it and drag stuff how you want and change the appearance. I'm going to show you the easy way to get started with legacy dialogues and start first with the bar chart. Now, you can use a bar chart to look at frequencies. How many times do we see this option chosen? Or you can use a bar chart to compare two or more groups on their means. We're going to look just at a bar chart for frequency distribution today. In this bar chart, you could cluster or have several different independent variables represented, but we're going to start with a simple one. So click Simple and Define. And then you can pick a variable and put it in on the category axis to see how often that option is chosen. So for example, let's look at something like, how often do you wear your seatbelt? All right. In this case, the options that people could choose were never, sometimes, always. So we'll look at the different responses we get. And the bar chart by default is going to show us the frequency, the number of cases. You could do other options, and if you wanted to compare two groups on means, you could switch this to other statistic and tell it to do the means for a dependent variable. So this is a good way to show a graph if you're running a t-test, for example. But today, again, we're going to just do a frequency distribution, the number of people who picked different kinds of options for how often you wear your seatbelt. If we click OK, the bar chart that we get will show the label instead of the number if you've got those value labels marked in your SPSS dataset. And it shows for the number of students we had that a lot of them picked always. The count or frequency is over here. A handful of people said sometimes, and just a few people said never. Now, this isn't too bad for a start with a bar chart, but there's some things we'd want to change. So we're going to double click on the bar chart. I'd like to change the word count to frequency. You might have to click or kind of double click until I get it pulled up, because that's more commonly used in publications. And we also ought to have access labels that have good titles. Let's maybe change this. This is the actual question from the survey. Let's change it to seat belt wearing frequency. Okay, so it's a little more concise and everything's capitalized like it's a title. We can also, if we click on the chart, find a way to insert a title. I'm going to take a minute across here and look and go, hey, there's title. So I could put up here an all-inclusive title for my graph, frequency of seat belt wearing for Psych 2231 undergraduate students. Right? And if I wanted, I can change the colors on these bars. If I double click, the first time it's going to highlight all the bars, and I could make them, say, teal. Here, I will close this out and show you that if you double click on the bar, it pulls that box up. You can also click again on just one bar, like get it to the point. See, now it's just selecting this always one, and I could change this one to blue. I could click, and I've just got this one. Maybe I want to make that one purple. And maybe I want this one for never to be red for danger. Okay. So we can make our graph look a little bit more like something that could be published. Remember that journals don't publish in color, so maybe instead of colors, if you double click here again, you might want to do patterns. Let's see, where do we have patterns? With the fill. Oh, there it was, hang on. We could go to pattern, and we could pick, small dots for one with a white background. And we could pick stripes. White background's probably good. And then we could pick a nice solid color. You can also do different shades of gray if you're going to be printing in black and white or thinking about a journal. And this isn't too busy or distracting. APA format also likes for us to take away these background labels. So if I double click there, I can tell it I don't, I want those white. I really don't want those lines. And that even makes our graph a little more clean. So here's a bar chart. Once you close this out, it puts these things in. And now you could copy or use snip to put this into your manuscript. The second kind of graph that we want to do is a histogram. And a histogram is for continuous data. Best for interval or ratio, can be used for ordinal, but some people would disagree with that. So best used for interval and ratio data. Let's say we wanted to make a histogram for how many hours of sleep that students get per night. We could go ahead and put the title in here, hours per sleep weeknights. This is the average hours for Psych 2231 students. You want to make your title descriptive enough that a reader who's unfamiliar to your work can pick up pretty quickly what you've got going on. And we pick continue. That normal curve will give us an idea about whether we've got a mesokurtic distribution, some skew, something really tall and leptokurtic, something flat or platykurtic. So it's nice to display that normal curve to help you eyeball what your graph is like. And again, there's our histogram. APA tends to like to get rid of these grid lines, so I'm going to double click on them and make those lines white to make it a little cleaner. And then I can see that for hours of sleep, it's fairly normally distributed. It's a little tall, so you might call it leptokurtic, with the average amount of sleep being 6.4 hours during the week, and the standard deviation and the sample size up here. And again, you can play with the colors. There's other things you could look around and try to change up here, but here is a nice clean histogram if you were asked for that for your descriptive data. The last ones I want to show you are box and whisker plot and stem and leaf plot. And I'm sure that there is some way to get to those here. We'll look at scatter plots for correlations in a different segment. But I think the easiest way to do those kind of graphs is actually to use Explore. And so we might use Explore, say, for instance, for age. And we can get descriptive statistics, plots, or both. And so it will, by default, give you the descriptive statistics. You want to make sure on plots that you've got a box plot and stem and leaf checked. Hey, look, we could do a histogram again, and we'll get all kinds of graphs. So we click continue and OK. And for that variable, we've got all the descriptives. I actually had an option selected to get extreme values that might be 2 standard deviations, 3 standard deviations away, like outliers or some of the more extreme scores. Here's our histogram. Here's our stem and leaf plot, which is another way of seeing the frequency, but if you take the histogram and lay it on its side, that's what we get for stem and leaf. So again, take a stem and leaf and kind of turn it this way, and that's doing the same thing as a histogram, just here it's numbers and here it's bars. And then here is the box and whisker plot that is really good for ordinal data because it's based on the median. The dark line here is the median, and the thicker the line, the more students have picked that score that's at the median. The box that's blue represents the 25th percentile and the 75th percentile, or the middle 50% of the data. And these whiskers on the box plot, sometimes called a box and whisker plot, indicate the 10th percentile and the 90th. So any scores that are beyond that are a little bit unusual. Scores that are 2 or more standard deviations away are shown with a circle, and the number tells you the case in your data set for that particular person, so you could go look them up. Anything with a star is about 3 standard deviations away, so these are outliers. These are ones that are farther away from the mean. So again, if I looked at case 23 here and went back to the data set, I could figure out that person was an outlier because they were 45 years old. So we could start to figure out who are the people that stand out. So hopefully this gives you an introduction to 3 different ways to look at frequencies: bar charts, histograms, 4 actually, stem and leaf, and box and whisker, so that you could graphically see what's going on with your sample of data in terms of its central tendency and variability. Thank you.